there. This is Noveljutsu, and I'm your host, Raelyn. Hey guys, this episode is long overdue, isn't it? I'm sorry it's so late. While I don't mean to make empty excuses, it's worth letting you know the reasons for this, as both these issues may affect how frequently I can post new videos. So the first reason this video is so late is a happy one. I've been really hard at work getting my debut novel ready for publication. My historical fantasy, The Wolf's Name, will be coming out this year, and the last several months have been spent on edits, cover designs, and brainstorming methods to market the book. It has kept me very, very busy, and I do hope to be able to share more about that with you here very soon. Now, I'm not usually that open about personal stuff online, but it will affect my posting schedule, so the second reason I'm late with this video is that last year a close family member of mine experienced a very serious health issue. It's not virus related, but it is an ongoing issue that requires a lot of attention and effort from the rest of my family. Between regular life, getting my novel ready for publication, and now this health crisis, I simply haven't had the time or mental bandwidth to do much for my channel. I know that's not ideal, but I want to assure you that I have no plans to quit posting videos. I still have a lot of content planned for this channel, so I just hope you can be patient with me as I take more time to get that content out. So thank you, sorry, and bear with me. With that said, you've waited a while for this video, so let's get into it. As always, we have the usual disclaimers. This video is not meant to be all-encompassing. If your story requires complete scientific accuracy, please do further research. And while we'll be discussing how water features work on an Earth-like world, feel free to take what you learn in this video as inspiration for a world that doesn't work like Earth. How would your world work, and what kind of stories would play out in a place like that? In the last episode, we discussed the physical landforms of your world, how they're created, and where they're most likely to form. But if your story contains an Earth-like world with Earth-like geography and Earth-like plants, creatures, and people to inhabit it, your physical landforms might be less important to the development of your world than its water features, at least to the development of the people and cultures of your world. Unfortunately, water features are a common place for world builders to mess up, including myself. See this map I drew many years ago for a world I was developing? Wrong! But with a basic understanding of how water features work, you can build a world that makes sense, and even one that can promote interesting development or a thrilling conflict in your story. So let's take a look at a few common water features and how they work. As a common place to put boundaries between towns and nations, as a source of fresh drinking water for people, livestock, and crops, and as a means for travel and trade, rivers are likely to be one of the most important features on your map. They're also one of the most common places for world builders to go wrong. Again, I refer you to my own map of wrongness. To understand how rivers work, you need to understand two important things about them. First, rivers flow from areas of higher elevation to levels of lower elevation. This means that rivers are born in high places, like from glacial melt in the mountains, and they flow downward until they reach the sea, get stuck in a place they can't escape from, or they dry up. Second, on their journey toward the sea, rivers will always take the path of least resistance. While they will erode the geography around them over time, they're not going to bore a hole straight through a mile of hard rock if there's an easier path that takes them around it. And this is where I and others have often messed up, it also means rivers very rarely fork into new rivers, as it's unlikely for them to find two equally accessible and easy to follow paths at the same time. Rivers may part temporarily and rejoin around an obstacle in their path, such as a small island, or they may form deltas as they meet the sea or another body of water, but they very rarely split into two rivers that go on separate journeys. Instead, rivers will converge with other rivers as both meet on a path of least resistance and flow down it together. Again, I refer you to my map of mistakes. Look at these forking rivers. Wrong! All wrong! Because of this, you will find areas of high elevation, such as mountains, will often have an abundance of streams, but those streams will be narrower and faster moving. I mentioned this in the last video on geography, but young streams, which is to say streams nearer to their source, are likely to flow straighter and steeper and will erode deep, V-shaped valleys rather than wide ones. As those streams age, however, and as they join up with other streams and become rivers, they will widen and may have floodplains. They will slow down and start to meander in fairly predictable back and forth curves. At low elevations near the sea, rivers will be much less commonly found than streams are in the mountains, but they're more likely to be large and broad. The flow of a river can be affected by its source, by the season of the year, and by the weather. For example, rivers fed from and nearer to a glacier tend to have a flooding season as the glacier melts faster in the spring and releases a rush of water. This can make a river dangerous, but is also prime time for exciting water activities such as whitewater rafting. But by the summer, that flooding disappears and water levels go down significantly. During the winter, the glacier then refreezes and is ready to start the process all over again in the spring. For other examples of how a river's flow can be affected, rivers primarily fed through rain can also experience flash floods during storms. There are also seasonal rivers where water flows for part of the year but dries up entirely during hotter months. The flooding of rivers can be very dangerous and cause a lot of damage. There can be damage to the local wildlife, and there can be a lot of damage to local civilizations. People in a flooded town or city may end up confined to their homes. Visitors may find themselves unable to leave as all modes of transport get cut off. And the cleanup of this damage can take a very long time and be very expensive. In places where rivers see regular flooding seasons, however, that flooding can actually be beneficial to the people who live there. The flooding of the Nile, for example, deposits nutrient-rich silt over its floodplains, and when the water recedes, these nutrients remain and make the land very fertile. This flooding was so important for the growth of crops and therefore for the people who lived there that the ancient Egyptian calendar was actually based on the flooding of the Nile, with the 3 seasons divided among when the Nile was flooded, when it was time to grow those crops, and when it was time to harvest them. In turn, this abundance of healthy crops allowed for ancient Egypt to become quite the powerhouse in its day. When basic needs such as food are met easily with an abundance for everyone, it allows for development and a focus elsewhere, such as on art and culture, technological innovation, warfare. I didn't say it was always good things. So consider how the rivers in your world will affect the local plant, animal, and humanoid life. Do they get their food from the river? How easy is the river to travel? How do your people deal with flooding? Is it harmful or beneficial to them? Think about how the kinds of water activities they participate in might change over the seasons, or how they might have water activities unique to each culture on your world. How have your people either biologically or technologically adapted to get past dangerous rivers or get the resources they need from them? Or perhaps do those dangerous rivers protect them from outside forces or enemies? If you're someone who gets story ideas from your world building, there's a lot of interesting ways your rivers might pose as story prompts or create conflict for the characters in your world. But rivers don't last. As rivers erode the landscape around them, they may uncover new paths of least resistance and change course. What happens to the places that depended on a river that's no longer there? Rivers may disappear in other ways. Sometimes they might disappear below ground if the rock beneath them is easily eroded. Those underground rivers may later re-emerge on the surface if the surface dips low enough for the river to exit while still continuing its downward journey toward the sea. But while rivers always make their way toward the sea, they don't always meet it. Old rivers making a long, arduous journey through a hot, dry climate may dry up before they reach the ocean. Otherwise, a river may wind into a basin and become... Rivers and streams may always seek the path of least resistance on their journey, but sometimes there isn't one. Sometimes they flow into a bowl of land and there is nowhere for them to escape. As the river continues to flow into that bowl, the bowl fills up and forms a lake or pond. As a result of the amount of water in them, lakes do tend to be wider than ponds, but that isn't actually the difference between them. The fundamental difference between a lake and a pond is not its width, but its depth. A pond is shallower and all its water lies in what is called the photic zone, meaning it's shallow enough that sunlight reaches the bottom of it. This means that plants grow not only on the pond's surface, but also at its bottom. To be classified as a lake, however, part of the lake must dip below the photic zone and into the aphotic zone, meaning it will have parts that go too deep for sunlight to reach. As such, plant life will be unable to survive at the lowest parts of a lake. Once a river fills a lake enough to discover an exit, the water will then flow out, and the river will continue its journey toward the sea. Because water always seeks the easiest escape, it means that while a lake can be fed by more than one stream, it will only have one river exiting it. But sometimes a lake fills up and still can't find an escape. Water keeps flowing into the lake, but evaporation limits how high that water can rise, and the water can't find an exit. These exitless basins are called endorheic, closed, or terminal basins, and include some of the largest lakes known to the world, including the Caspian Sea. An important thing to note about these basins, though, is that they are saltwater basins. While a particularly young terminal basin might not be saltwater yet, the flow of water into the basin will continually bring with it new minerals and sediment, depositing them into the lake. But since the only escape for the water is through underground seepage or through evaporation, which leaves that sediment behind, it means that over time the concentration of those deposited minerals gets higher, the saline content increases, and the lake becomes a saltwater lake. This could make for interesting world building in your fantasy or sci-fi world. Maybe there's a mineral that's really important to the growth of some sort of magical plant, and terminal basins in your world collect so much of that mineral that these plants are really abundant there. Or maybe you have minerals that are incredibly poisonous and cause magical diseases. So maybe the people in your world stay very far away from any kind of basin like this. There's a lot of really cool ideas that you could have with this. I might have to use one of these ideas myself. Finally, freshwater lakes and ponds are a great source of food for your human civilizations. The calmer water allows for the growth of plant life, which in turn allows for the existence of animal life and complex aquatic ecosystems the people in your world can benefit from. Wetlands are biologically distinct areas of land flooded by water. They might be flooded for a season of each year, or they may be more permanent. But the flooding of wetlands causes them to have oxygen-free, hydric soils, and thus vegetation adapted to that harsh environment. Those low oxygen levels and unique plant life are what's going to distinguish a true wetland from a swath of land that might flood after a bad storm, but doesn't ordinarily see much flooding. Frequently transitional zones between water bodies and dry land, you are likely to find wetlands near a sea, lake, stream, or places where groundwater surfaces. Wetlands are known by many different names across the world, and there are lots of ways to categorize them based on qualifications like whether they're fresh, brackish, or saltwater, or whether the source of their flooding is from oceans, rivers and streams, lakes, storms, groundwater, or so on. But it's not unheard of for wetlands to be a mix of these things, sometimes making them difficult to classify. For our purposes, there are 4 main types of wetlands. A marsh is a wetland with neutral to alkaline water, where the plant life is mostly comprised of soft-stemmed species, such as grasses or reeds. In contrast to a marsh, a swamp is dominated by woody plants, your trees and shrubs. Bogs tend to be more isolated bodies of water fed by rain. Their low oxygen levels make for the slow, incomplete decay of dead plants and the buildup of peat. Bogs have acidic, brown water and are likely to be home to mosses, heather, and even carnivorous plants that make up for the low nutrient levels by consuming insects. This combination of acidic water and low oxygen levels means that bogs have been able to partially preserve bog bodies in sometimes amazing condition for years, centuries, and even millennia, with one of the oldest discovered bog bodies dating back to 8000 BCE. But while bogs may be great at preserving certain biological material like skin or leather, hair, nails, the acidity usually means that they're not so good at preserving bones. Fens, like bogs, are also characterized by the buildup of peat. but unlike bogs, are usually fed by rising groundwater. That more constant supply of water means that fens tend to have more water movement than bogs, which allows them to be more alkaline and have higher mineral content. Fens, however, can and often do turn into bogs as the accumulation of peat can eventually reduce or block water flow, making the wetland more acidic over time. The plant life in fens is usually dominated by sedges and mosses. Due to the low oxygen and sometimes low nutrient nature of wetlands, they often have very unique biodiversity with plant life specially adapted to wetland environments, and therefore fauna likewise adapted to the plants and other critters available for their diets. Also, due to the nature of their soil and water, wetlands often have biological processes which can make them great at filtering heavy metals and other sediment from runoff and wastewater. It means wetlands act as a sort of buffer zone, preventing large amounts of potentially harmful substances from reaching the ocean in runoff. But because of this, some wetlands will emit methane gas and can also contribute to climate change. So that's wetlands in a nutshell, but of course we can't conclude a discussion on water features without first discussing. On Earth, the ocean comprises 97% of Earth's water and covers a little over 2/3 of its surface. It's comprised of salt water and plays an enormous role in climate, weather, and the water cycle. I tried to research the difference between oceans, seas, and bays and got mixed results. It seems that colloquially, seas and oceans are often interchangeable terms. Indeed, the names of certain oceans, seas, or even lakes seem to suggest a certain degree of haphazardness in how we refer to these segments of the biggest body of water on Earth. Sometimes a sea is just a sea because that's what they first started calling it. So if you're coming up with names for the seas in your world, you'll want to consider how strict the people who inhabit your world are in how they categorize oceans versus seas. If they're not strict, you might consider who originally named the body of water, or if there are trends among different populations or cultural groups. Maybe you'll even have a group of people who have their own word for it entirely. However, when you get a little more scientific about the actual differences between a sea and an ocean, you'll find that some distinctions can be made. Essentially, both ocean and sea are terms to subdivide the entirety of the ocean, being the singular saltwater body that covers our planet. The ocean is divided into 5 recognized smaller oceans: your Pacific, Atlantic, Arctic, Antarctic, and Indian Oceans. But some of those oceans are further subdivided into smaller oceans yet, such as the North and South Atlantic Oceans and the North and South Pacific Oceans. Altogether, those form the 7 seas you've probably heard of. Yes, the 7 seas, not the 7 oceans. Again, we interchange these words a lot. But what about those seas? The term sea usually refers to a body of water that is smaller than an ocean and is at least partly bordered by land. But there can be exceptions to that rule. One exception may be a sea that is bounded by ocean currents instead of land. Or you may find a completely enclosed body of water that is large enough to earn the name of sea, even though it's technically a really big lake, such as the Caspian Sea or the Sea of Galilee. Like lakes, oceans are also comprised of different zones based on the reach of sunlight. These zones affect the kind of life that inhabit them, as the deeper in the ocean, the more life has to adapt to little to no vegetation, lower temperatures, higher salt content, and increasing amounts of water pressure. The uppermost zone is, as with lakes and ponds, the photic zone, which extends to about 200 meters below the water's surface. Sunlight can penetrate through this zone, allowing for photosynthesis and thus the existence of plant life. That plant life, in turn, provides nutrients and hiding places for various sea critters. In fact, about 90% of known marine animal life exists within this zone. The next zone down is the mesopelagic zone. This zone begins where the photic zone leaves off, where 1% of sunlight still penetrates through the water at about 200 meters, and it extends down until no sunlight penetrates, at around 1,000 meters below the surface of the water. Here we find fascinating creatures adapted to life in low amounts of light, such as giant squids and jellyfish. Next we have the bathyal zone. It extends from 1,000 meters deep to 4,000 meters deep. Due to the lack of light, there are no known plant species in this zone, and animal life must adapt to an absence of light and low levels of nutrients. While not true of all species, some of the animals that live in this zone have no need of eyes and thus may have very small ones or none at all. Likewise, life in this zone will have adapted in other ways to conserve energy. They'll have slow metabolism and often weak muscles compared to their mesopelagic or photic zone neighbors. Expect to find species such as anglerfish, octopi, and sharks. Finally, we have the abyssal zone, which is just an awesome name for the ocean. This zone extends between 4,000 meters and 6,000 meters deep, and it makes up about 83% of the entire ocean. An absence of plant life means that any oxygen found in this zone mostly comes from ice that melted a long time ago. Water at the seafloor will actually contain no oxygen at all, and any species that find themselves wandering into that region will suffocate if they can't find their way back. The ecosystems that exist this deep below the surface are unique because instead of the food chain beginning with plant life, animals that live here instead have to feed on the dead organic material that drifts down from the zones above. Here, animal life must adapt to darkness, cold, limited oxygen, and intense water pressure. You might find creatures such as crustaceans, snails, and some really weird fishes. Apart from those zones, another important feature of oceans are their currents. Surface currents can be affected by the rotation of the earth, the tides, and by wind, which can have an effect on not just the water immediately near the surface, but all through the photic zone. Deep ocean currents are currents below that, and they're affected by the interaction of water with differing densities, which can be caused by differing temperatures and differing saline content. Ocean currents are important for life. First, the interaction of surface and deep sea currents allows for the exchange of nutrients, which feeds plant or animal species within the 4 ocean zones. But ocean currents are also great at absorbing and distributing heat more evenly around the Earth. For now. Climate change threatens the effectiveness of ocean currents as rising sea temperatures mean ocean currents slow down and may, theoretically, stop one day. Maybe that day is soon to come on your invented world, but even if it's not, your oceans may still pose both a threat and a boon to any people who live near them. In our world, oceans are an important source of food, religious and cultural significance, and transportation for many modern and historical peoples around the world. But oceans are also notorious for tsunami, riptides, violent sea storms, and even predatory animals that can threaten the safety of boats and swimmers. How your people view the ocean is likely to depend in part on how tied to it their culture and lifestyle is, and, in a similar vein, how much time they spend on the water. The more your people derive food and leisure from the ocean, the more time they spend getting their sea legs, the more likely they are to feel a certain closeness to the ocean, a certain respect or even reverence for it. However, people who depend less on the sea for sustenance and their livelihoods, but still live close enough to deal with the dangers of the sea, are far more likely to view the sea with hostility. Regardless of whether your people love or fear the ocean, it's an important and often faster route for trade than land routes are, especially if the land is particularly mountainous, which can make passage for caravans very difficult. So if your little caravan opts for the mountain passage instead of a sea route, ask yourself why those people would have developed that mountain passage in the first place when they had a perfectly accessible sea route to wherever they needed to go. Are their religious beliefs about the evil god of the sea that serious and widespread? Or is there something lurking in the ocean that truly does make the sea the less safe option? Are there people who brave the ocean waters anyway? When people talk about the water features of a made-up world, they don't usually talk about water features of the frozen variety, but I thought it was at least worth a special mention here. While people often think of snow as making a landscape scene barren and dead, and while cold and ice definitely can make for a challenging existence, in truth, snowfall also hydrates the land as it melts, giving important nourishment to seeds that will sprout and grow into the native plant life in the spring. As already mentioned, glaciers are also an important source for many streams, which carry the glacier's water from the mountains to other parts of the land, where it can allow for wildlife to flourish and crops to grow. Of course, glaciers can also be important to the life and habitat of many Arctic creatures, like polar bears, who are so dependent on them that the melting of the glaciers is enough to threaten the polar bear's very existence. So if you're setting your story in a cold world or a place of high elevation, as you're considering what challenges that will make for those who live there and how they've adapted to those challenges, you might also want to consider how the freezing and melting of the snow and glaciers during the seasons would affect the wildlife and your people's culture, language, livelihoods, and way of life. So, as you might have guessed from hints I've made during this video, my earlier attempts at making maps of my own made-up worlds fell into some common world-building mistakes. When I first made a map for the world of my story for Project Noveljutsu, my rivers were all wrong. I don't think I had any lakes unless they were terminal basins, and there was not a marsh or swamp to be seen. Over the years since then, I've learned a few things, so I took the map that I redrew in the last video, and I've started adding my water features. You'll notice none of them have names yet. That's something we'll discuss in a future episode. But I've drawn in the major rivers and lakes and marked some likely spots for the largest, most notorious wetlands. My map covers too large of an area to include every tiny stream or puddle, but for my purposes right now, I think this does the trick. If you did the challenge from the last video, go ahead and take the map that you made, and look for the most likely places for rivers, lakes, and other water features and draw them in. That's it for this video. Stay tuned for more world building videos coming as soon as I can make them. If you learned something from this video, go ahead and give it a like or a share, subscribe, you know the drill. Links to all my social media are in the description box below, and I will see you next time.